And the first question says construct the angle bisector for the angle above. So since I'm doing this online and I can't measure what the angle is, so what I'm going to do is I'm going to assume an angle value for this. Let's say this is that's at 60. Okay. So I'm going to show you how to draw the angle bisector for the angle 60. So what we do is, in our case, obviously they've made the lines, but I'm going to draw new ones. This is the first line. And then I'm going to use the protractor to measure the angle over here. And 60 is right over here. So next what we're going to do is we're going to draw another line. This is a line for 60. So now that we have our lines, we're going to draw the angle bisector for 60 over here. This angle is 60, because that's what we're assuming. So we're going to use our compass to draw arcs. So I'm gonna, since this line over here is like more than 6 centimeters, I'm gonna open this to 3 centimeters. Like there's no restriction that you can open it to like any, but it needs to be less than the complete length. So I'm gonna open it to 3 centimeters over here. And what I'm going to do is I'm going to draw an arc over here on this line. And then I'm going to draw an arc using the same distance on this line. So we have 2 arcs over here. Then I'm going to move the compass to the point where we drew the arc. And now we're going to draw another arc over here. And another over here. So as you can see, we have this intersection of 2 arcs. Now what we're going to do is we're going to connect the intersection with the center. This line passing exactly through the intersection of these 2 lines and the arcs. When we measure the angle over here, as you can see, it's exactly 30. It's half of 60. So this line, this is your angle bisector. It's bisecting the angle. It's dividing it into 2 equal parts. Both these parts, this is 30 degrees over here and 30 degrees over here. So this is how you draw an angle bisector for any given angle. They can give you like the measurement of the angle. They can ask you to draw it like I did. Or they can give you the lines and they ask you to measure the angle first and then draw the angle bisector for this. So that's how you draw angle bisectors. The next question says 1.5, 2, 2.53, and 3.5, and so on. These are the numbers in a sequence. We have to work out the nth term. So to work out the nth term, what you do is you find the common difference first. So if you subtract 2 and 1.5, you get 0.5. And if you subtract 2.5 and 2, you again get 0.5. So as you can see, we have a common difference of 0.5. So whatever the common difference is, always remember that when you're trying to find the nth term, you multiply the common difference with n. And since the common difference was being added to each consecutive term, so it's going to be positive 0.5 times n. So now let's assume this is our nth term. So to find the first term, I will do 0.5 times 1, and that's 0.5. As you can see, the first term in the sequence is 1.5, not 0.5, which means we need to add 1 to the nth term equation that we have over here. So now let's say this is our nth term. So if I try to find the second term, so that's going to be 0.5 times 2 plus 1. Now 0.5 times 2 is 1, and 1 plus 1 is 2, which gives us second term, which means this could be the nth term equation. Let's find another term. Let's say the fourth term. So T4 is going to be 0.5 times 4 plus 1. Now 0.5 times 4 is 2. 2 plus 1 is 3, which means, yes, this is the nth term. Now in the next part, it says work out the 20th term. So we need to find T20. So T20 is going to be 0.5 times 20. because we're trying to find the 20th value. So we replace n with 20 and then plus 1. So that's 10 plus 1, and that is 11. That is your answer. Next question says solve 8y plus 2 equals to 30 plus 6y. So whenever you're solving linear equations, first step is to see whether we have any like terms. So as you can see, we have a like term of 8y and 6y on both sides. And similarly, we have like terms of 2 and 30 because they're both constants. So what we're going to do is that we're going to collect the like terms on each side. So for that, I'm going to move 6y over here and move 2 over here. So it's going to be 8y minus 6y equals to 30 minus 2. 8y minus 6y is 2y. 30 minus 2 is 28. So y is going to be 28 divided by 2, and that is 14. That's your answer. And the next question says ABC and DEF are similar triangles. Find the length of EF. So first, to find the length of EF, we need to figure out what is the length of BC. So in order to find the length of BC, we can use Pythagoras. Why? Because it's a right angle triangle. And in a right angle triangle, if you have two lengths and third length is missing, you can easily use Pythagoras to find the length. So it's going to be BC square, hypotenuse square equals to 24 square plus 7 square. BC square equals to 576 plus 7 square, which is 49. So that's going to be 625. So BC is going to be square root of 625, and that is 25 centimeters. So this is 25. Now we're trying to find the length of EF. So remember that whenever we have two similar shapes, any similar shape, there's a scale factor which is used to enlarge or make the size smaller for the other shape. So in our case, if we're comparing from triangle ABC to DEF, if it's being enlarged, that means the lengths are increased by scale factor, and the scale factor is common for all lengths. So to increase 7 to 42, we multiply 7 by 6, which means 6 is your scale factor. So to find EF, we'll multiply 25 by 6, and that is going to give us 150 centimeters. So that is your length of EF.